All right, we're going to continue on from the last lesson, add just a small piece to it, hopefully not too much more complicated. So radicals can also have variables inside them. So in the previous lesson, you saw how to simplify just numerical expressions. Now we're going to simplify numerical and variable expressions underneath roots. So how to simplify a radical with variables? Start with simplifying any numbers under your radical as you did in that last lesson. Then for each variable, you're going to divide the degree of the variable by the index. So the degree is going to be whatever exponent is on that variable, and divide it by the index, which is the little number on your root symbol. Your result of that division is going to be the degree on the variable outside the radical. So if you have, we'll get to some examples, but if underneath you have maybe a square root, you have x to the 6th, well, 6 divided by 2 is going to give you 3. That means outside of the root is going to be x to the 3rd. Anything that is a remainder, so 6 was divisible by 2, but maybe instead of 6, you had 7. 7 is not divisible by 2, but you have 3 with 1 left over. Anything left over goes on the inside of the radical. Similar to the last lesson, if you have other ways to get the right answer, perfectly fine as long as you get the right answer. Straight into some examples. So you want to make sure you remind yourself your little degree on any of them, the index here. So if it's not anything, it's a 2. If there is something, it's whatever it is. We're going to simplify the number part first. Well, in this case, we have like the square root of 9. I'm going to separate these into 3. You don't have to do this. You don't have to do it at all, or you can do it just for this first one so you can kind of see. So you're going to take the square root of 9. That's pretty simple. Square root of 9 is 3. The square root of 8 to the 4th, well, you have 4, and you're going to divide by 2. That gives you 2. So that means outside of the root, you're going to have a squared. And how many are left? None, because 4 divided by 2 is just 2. And then b to the 3rd, you're going to divide that by 2 also. Well, that's going to give you 1. 3 divided by 2 is 1 outside of the root, but there is a remainder of 1. So underneath the root is also b. So your final answer is 3a squared b square root of b. In your next example, your index is 3. So we're going to start by simplifying the cubed root of 16. So for that, since that's not nice and easy, we have to simplify it like before. You want to find your prime factors of 16, which happen to be 2 times 2 times 2 times 2. Our index is 3, so we need groups of 3. That one group is going to come outside of your root by itself, like that. The other one we'll leave for a moment. We'll come back to it when we get to what's underneath our root. Next, we're going to move on to our x's. We have 4. We need groups of 3. There is one group of 3. 4 divided by 3 gives you 1 outside. We are going to have some left over. So let's just off to the side here, leave some gap because you might have a y and you might have a z. Let's go underneath our cube root. This 2 that's right here, not in a group, goes by itself underneath the root. Our x to the 4th, well, we needed 3 to come out. We did that. We have 1 left over. So we have just x. Y to the 5th, well, we need groups of 3. So we have one of those. We have one group of 3. So 1 group of 3. And how many are going to be left over? We're going to have 2 left over. And z to the 2nd, we need groups of 3. Well, we don't have any groups of 3 for that. So none of them can come out. We're just going to leave this z squared underneath. So to rewrite this nicely, it's one big answer. 2xy, and then the cube root of 2xy squared z squared. In your next example, we have a 5m squared already on the outside. We're going to take the square root of 18, n to the 5th, n to the 7th. And that 5m squared is right in front, means we have multiplication. So once we get our new simplified square root, we're then going to times it by that 5m squared. So we're going to start with the square root of 18. We need prime factors. That is 2 times 3 times 3. Our index on the square root is a 2. We're looking for groups of 2, which we have right here. So the pair of 3 is going to come out. So we're going to keep that 5m squared. Now times this group of 3 comes outside of the square root as a 3. Underneath our square root, the 2 does not have a pair, so it stays underneath. We move on to our m to the 5th under that square root. Well, we need groups of 2. M to the 5th means we have 2 groups of 2 and 1 left over. And n to the 7th, we need groups of 2 again. Well, if you count by 2s, you get 2, 4, 6. That's 3 of them come outside. So n to the 3rd. But we only got up to 6, which means we have 1 more underneath. And now we need to finish simplifying by actually doing that multiplication. 5 times 3 is 15. And with your exponent rules, m to the 5th times m to the 5th, we've learned is m to the 4th. n to the 3rd doesn't have anything. And your square root of 2mn. So 15m to the 4th, m to the 3rd, square root of 2mn. I'm going to pause the video here. I'm not going to pause the video. I'm going to stop the video, and I want you to try this one on your own. There's going to be a second video with this one in there after you've tried it on your own.